Okay, so welcome back, my dear students. So, uh, one of my student has asked me to solve question number 4 and question number 5 related to exercise 13.4, and this particular question is related to surface areas and volumes, and which is there in CBSE Maths 10th standard. Okay, so my student has asked me to explain him uh, for this question number 4 and question number 5. So question number 4 I am putting the video, and in my next video I will be putting for question number 5, and this is going to be beneficial even for other students also. Okay, so I thought that why not to share it with everyone. Okay, so that it will be beneficial not only for my student, you can say one of the student, or it will be benefitable for others also. So let us see that what actually it is. So question number 4, actually it says that it is related to frustum of a cone actually. So in this particular chapter, we studied about surface areas of different solids. We discussed about surface areas of cube, surface areas of cuboid, so curved surface area, then total surface area. Okay, then we discussed about surface area of a cylinder, then curved surface area of a cone, then curved surface area of a sphere, hemisphere. So all these particular solids, we discussed about surface areas and even volumes also in previous question exercise 13.1, 13.2 and 13.3. Now in 13.4, especially this particular exercise is meant for frustum of a cone. So frustum of a cone actually what it is, when the cone is cut, some portion of it is cut from the top. Okay, so just like we are having some cup we do have in our home and all, so those cups and all, or you can say pressure cooker, so all these will be an example for frustum of a cone. So this frustum of a cone, when the cone is being cut, not from the middle always, it can be cut from any place, so there will be a definite height. With the definite height, this cone will be having two radius now. Earlier, one cone used to have only one radius at the bottom surface, because the top surface is just like the vertices of a triangle. So it is just like a triangle, the shape is. But now in this case, when the cone is cut, a portion of it is cut, then it will be having two radius. One radius will be at the bottom surface and one radius will be at the top surface. There may be circumstances when the top radius will be more than the bottom surface, or bottom surface will be having more radius than top surface. Okay, so these two cases may be different. If the radius, one of my student, he asked that if the radius will be equal, if R1 will be equal to R2, bottom surface and top surface, both radius will be equal, then whether it will be called as frustum of cone. Then I said that no, it will not be called as frustum of cone, it will be cylinder only. Okay, so when the radius of top surface and bottom surface, it will be equal, so it will become radius. Sorry, it will become cylinder. So that cylinder we will be solving by uh, utilizing the formulas of cylinder. Okay, so in this particular question, even I have written the formulas what we are going to use for the frustum of a cone. So right hand side I have already shown here. So that right hand side you can see formulas frustum of a cone. So curved surface area we can find out by utilizing the formula pi into L into R1 plus R2. So L is the slant height of the cone, and these informations will be given to us in questions. Similarly, total surface area when we are finding, so it will include curved surface area plus the area of the bottom surface plus the area of top surface. Okay, so bottom surface and top surface, it is purely circular. So that's why this the formula is pi L into R1 plus R2 plus pi R1 square plus pi R2 square. Okay. Similarly, volume of the frustum of cone can be found by 1 by 3 pi h into R1 square plus R2 square plus R1 R2. If you will see clearly, it will be having similarity uh, among the formulas what we have studied in cone and the formulas what it is there in frustum of cone. Okay, so for a cone curved surface area we are writing as pi RL, whereas total surface area we are writing as pi RL plus pi R square. Okay, similarly volume of the frustum is this one, and volume of the cone actually it will be 1 by 3 pi R square H. Okay, so similarity is there, little bit difference will be there because it will be having two radius now due to that only, and L can be found out especially by utilizing the formula whole root h square plus r1 minus r2 whole square. So the same you can see that I have already solved the question and it is at the right place. Okay, now let us moving to the question now, and the question says that a container opened from the top. Okay, so just like it is a cup. So a container is opened from the top. Okay, and made up of a metal sheet is in the form of a frustum of a cone. So the frustum of a cone is in front of you. Okay, so the cone, what it is forming, the figure is in front of you. Okay, so the height it is given as 16 centimeter and radii of its lower and upper ends are 8 centimeter and 20 centimeter. So lower end you can say it is smaller and upper end it is bigger. So it is just like a cup in which we used to take milk, right? Okay. So the radius at the bottom surface it is 8 centimeter and the top surface it is 20 centimeter and the height is given to us as 16 centimeter. Okay. Now we need to find the cost of the milk which can completely fill the container. So first of all, we need to find out the volume of milk which can be, you can say, which this particular container will contain. Okay, will be able to have it. So that the volume of the milk that we need to find out. So volume of the milk will be equal to the volume of the container itself. So we will be utilizing the formula of volume of the frustum. Okay, so we are already having H, we are already having R1, we are already having R2. So by utilizing the formula that is 1 by 3 pi into H into R1 square plus R2 square plus R1 R2, we will be able to find out the volume of the milk. So we will put the value of pi is equal to 3.14 which is given to us, and H height is given as 16. Similarly R1, so R1 is 20 centimeter it is given to us, and R2 is given 8 centimeter, so 8 is square plus 20 is square, and R1 R2 is plus 20 into 8. So next step 1 by 3 into 3.14 into 16. So 20 square will become 400, 8 square will become 64, and 8 into 20 will become 160. And further, this 400 plus 64 plus 160 will be giving to us as 208. Okay, sorry, 624. And this 624 can be cancelled by 3, so it will become 208. And after multiplication of this 3.14 into 16 into 208, we will be getting 10,449.92 centimeter cube. Now, cost of the milk, it is given to us as rupees 20 per liter. So the main question here is conversion now. So our students they need to do conversion. So already our students they are knowing, and we all are knowing that 1000 centimeter cube will be equal to 1 liter. Okay. So this 10,449.92 centimeter cube will be divided by 1000 and it will be given to us as 10.44992 liter. Okay, so this 10,449.92 centimeter cube is converted to liter now. Okay, so now cost of the milk is rupees 20 per liter. So rupees 20 into 10.44992 liter. Okay, when it is multiplied, we are getting rupees 209. Okay, so the 200 rupees 209 will be the value of the uh, milk which this particular container will be able to contain. Then one another question is also involved in this particular question, that is also find the cost of metal sheet used to make the container if it costs rupees 8 per 100 centimeter square. Okay, so little bit some twist is there. So not an issue. We will be able to solve it by utilizing all the formulas which is there. Okay, so the values we have to put it here and we will get the answers. So total curved surface area if we are going to find, so you can see that in the formula it is clearly written that pi L into R1 plus R2 plus pi R1 square plus pi R2 square. So this is the total surface area of the container, that metal sheet which is used for making this frustum of cone. But one thing we have to understand, that the top of the container, it is opened, it is not closed. So it means pi R1 square in this particular case will not be there because that it is opened. So we cannot include it in total surface area. So in total surface area, the curved surface area will be included plus bottom surface area will be included. Okay. So it will be having pi L into R1 plus R2 plus pi R1 square. So pi R1 square is not there. So plus pi R2 square. Pi R1 square, here it has become 0. So pi R2 square. And L, how we can find out? We can see at the right hand side, I have already solved it. So L is equal to H square plus R1 minus R2 whole square. By putting the formulas, you can say values of H and R1 and R2, we can get, and after solving it, we have got 20 centimeters. So L is equal to 20 centimeters. Okay. So pi L into R1 plus R2 plus pi R2 square. So pi, the value again we have to take as 3.14 into. So pi is common to both of them. So that pi we will be taking it outside. And inside L is equal to 20 already we have solved. And R1 we are already knowing that it is 20 and R2 is 8. So 20 into in bracket 20 plus 8 and plus pi R2 square. So R2 is 8. So 8 square. Okay, so 3.14 into 560 plus 64 we have got, again 3.14 into 624 we have got it. Okay, and if we have solved it, so we got 1959 or 1959.36 centimeter square. So this is you can say the total curved surface area of the metal sheet which is used for making this particular container, right? So cost of metal sheet is given to us as rupees 8 per 100 centimeter square. Okay, per 100 centimeter square, it is rupees 8. So for 1 centimeter square, it will be rupees 8 by 100. Yes. And for 1959.36 centimeter square, we can write as rupees 8 by 100 into 1959.36 centimeter square. That will be the total cost of metal sheet. Yes or no? So the cost of metal sheet we can find by multiplying this 1959.36 centimeter square into 8 by 100. Okay. Then we are getting the value as rupees 156.75, and which will be the total cost of metal sheet used to make the container. Okay, so this particular question we have solved in this way, and direct formula based questions are there in this particular chapter. Somewhere some logic has to be applied. We need to apply a little bit logic. Like here we have applied the logic as the container is already opened from the top. But most of the time what it will be there, if suppose we will mug up and we want to write the same thing, then pi r2 square also, sorry, pi r1 square also we will add when we are finding total curved surface area, then our answer will be wrong. So in that case already it is given in the question, so we need to understand the question first. The question is already given that it is opened from the top, so there is no question of taking pi r1 square in total curved surface area. So this particular part we need to understand. We need to understand complete question logically. Okay. So very nice. So again, in my next video, I will be solving question number 5. So question number 5 also similar to it. It is there, and please share it with your friends. If you have liked it, please like it further and share it with your friends. And coming to you again with the next video for question number 5 immediately. Huh? So, bye.